Have you ever asked ChatGPT a question and it gave you a very confident but completely wrong answer? That's what we call as AI hallucination. Today, we are going to see not just why it happens, but also how we can reduce it using code examples. Let's dive in. In AI, hallucination is when a model makes a fact that don't exist. This happens because language models are trained to generate plausible text, not always truthful ones. So, when a model doesn't know the answer, it will just invent one. In casual chat, hallucinations are funny, but in areas like healthcare, finance, and law, this could be very dangerous. That's why researchers and engineers are spending a lot of time to reduce hallucinations. So, how we can fix hallucination? There are several strategies to reduce hallucination. The first one is strict prompting. So that's one of the strategy where you are instructing LLM to answer only from the verified sources, for example, or in or output I don't know answer if it doesn't know the answer exactly instead of making one up. Okay. The next method is retrieval-augmented generation. So this is to help the LLM to provide with the context. For example, you provide the source documentations for LLM to answer from, and if the required information or answer is not available in the related document, then you are instructing the LLM to output I don't know instead of making one up. And third method is sources and citations. By this way, you know every answer comes with a source and you can check, you get to know where the facts are actually coming from. Fourth method is self-check using embeddings. So we can also use similarity scores to compare and reduce hallucination. For example, we can use embeddings to compare the retrieved outputs LLM responses with the retrieved documents. If it is not matching, semantically matching, then we can flag it as possible hallucinations. Let's dive into a real world examples. I have created a set of questionnaires and also a list of methods that I have used to reduce hallucinations. Let's dive in. So here's a simple example for reducing hallucination. As you can see that I have already OpenAI API key that is set in an environment. I'm getting that key using .env. And so here are the retrieval documents, RAG documents. Basically, this is a very simple context that we are providing to LLM to produce an answer. So for example, if we have given a context saying that the sun is a star and located at the center of the solar system, and here I have mentioned it as the source is coming from I'm giving some name for the source like astronomy textbook. And similarly, I have also given another context, which is Mars is a planet often called the red planet. And I have also attached the source. So when LLM sees that type of question, it's going to give us a source. If it is a second method, so I have mentioned the citation, sources and citations is one of the method. So that will be retrieving from this metadata, which is space articles. Similarly, if you look at this one, Moon is Earth's only natural satellite. And metadata source is coming from metadata and source is coming from NASA fact sheet. So if you look at this one, this is using a Facebook AI similarity search, which produces this embeddings. And this is a common type of method, a RAG method to produce the embeddings. And here is a prompt template. So I'm instructing the LLM to be very strict. So you are a strict assistant and you need to use the provided context to answer the question. If the answer is not in the context, reply only with I don't know. So don't use prior knowledge. So even LLM is trained on a lot of vast amount of general knowledge. We are restricting the LLM to answer only based on the context that I have given, which is these are the three contexts that I have given. So similarly, I have also have a kind of context and question and response format. And here is a strict prompt. I'm using the input variables, context and questions, and template, which is a prompt template that we have declared. So here I have a retrieval QA from chain type, where I'm passing the LLM and also I'm using the retriever. And here I have a chain type stuff and also passing the strict prompt into it and return source documents equal to true. So in this case, retrieval QA with sources So this is with the sources. So we are passing the LLM and retriever. We are passing the retriever and stuff. So here embeddings, open AI embeddings is used to get the open AI key. We are getting it from the environment variable, and I have declared two functions, defined two functions. One is a helper function. The first one is QA with self-check. So I have mentioned one of the method is self-check, which means that producing the embeddings and also similarity scores to test and compare the retrieved answer, LLM answer, with the retrieved document. So document by documents, I mean the context that we have passed, like here. And I'm going to compare with this little function. I'm going to compare and get the similarity scores basically. So this one gives the actual similarity score, cosine similarity. Then we are passing the vector 1, which is LLM answer, and vector 2 is a retrieved document, which is a document that we have passed. So this is a strict. So we are invoking the query, and I have also defined the query here. So if you look at this, the answer vector, so it is coming from the embeddings and embed query with answer, and the source vectors embedding dot embed of query. So I'm getting all the sources from here and make an embeddings. And here, if not source vector, if no source vector is retrieved, then we are flagging it as hallucination. And the maximum similarity, we are getting the similarity scores and getting the max out of the similarity scores, and we are setting a threshold of 0.75 as a threshold, so that whenever we get the similarity scores like 0.70 for example, then it is going to flag it as hallucination. Otherwise it's going to return, because the similarity score is high, so it is most relevant, and so there is no flagging as hallucination. So that's why we are returning as answer if the similarity score is greater than 0.75. And these are some of the questions I have asked, which is a sun a planet, and who discovered gravity? So which is not in the context. Basically, we are not providing any information in our documents, retrieval documents, about gravity. So let's see whether it's hallucinating. So whether this cell check is actually flagging it as hallucination. And we have what is the capital of France. So this is also out of context, and it provides hallucination risk as an answer. And what color is the moon often called? So it is in the context. So we will be getting answer from the LLM. And does the moon have water? So this is not in the documents that we have provided. So this will be flagged as hallucination. So for example, so here I'm getting all the queries. So I have 5 queries, and I'm passing each query in different methods. The first thing is we have provided a strict instruction to the LLM to get the answer only from the context or the documents that we have provided using RAG. And so that's why it's going to follow only the instructions that we have passed. And the second method is with the sources and citations. So we have also this metadata attached to it for each and every document that we have passed. So for example, let me just go through that again. So these are the metadata. So when it is answering from this context, it's going to flag this as the relevant source. So that's what it is. So we are passing the question and getting the answers from the second method, which is the sources and citations. And the third method is using self-check. So which means like creating the embeddings and getting the similarity scores and comparing the similarity scores. For example, similarity scores that are below this threshold 0.75 or flagged as hallucination. If it is greater than the threshold, then it will give that appropriate answers for all the queries that we have passed. Okay, let's run this example. So these are the results we have got. So is the sun a planet? So that was our first question. And so using the first method strict prompt, we have got no, the sun is not a planet. So because we have already mentioned for the first one, strict prompt means we need the LLM has to use the sources that we have provided. We have already mentioned sun is a star, not a planet. So it has given a right answer. No, sun is not a planet. With sources, is the sun a planet? So here we also tagged metadata. We have given the metadata as astronomy textbook. So here we have got an answer, no, sun is not a planet, and it has also retrieved the metadata source, which is astronomy textbook here, alongside the answers that it has given. So similarly, self-check. So that's the third method that we have used, where it looks for the answers, and if it is similar, if the retrieved document and the LLM response is semantically similar, then it will the threshold is nearly higher than 0.75. So this has got a similarity score of 0.86, which is very good, which means that the retrieved document and the LLM answer is semantically similar, and that's why it has given the answer confidently, saying that no, sun is not a planet. I hope you found that demo helpful. Hallucinations are natural weaknesses of large language models. With the right guardrails, like having the right prompting, retrieval, citations and sources, and also validation, we can make AI far more reliable and trustworthy. I hope you like this video. If you like it, give a thumbs up and also subscribe for more AI tutorials. And let me know in the comments what are the funniest hallucinations you had with ChatGPT, for example. And I'll see you in the next video. Stay tuned.
This is the future. Evolution.